Look at you coming back for more fun and realization. My friends, we're going to talk server virtualization. You ready? Yeah, let's get started. Server virtualization, it's a process. It creates and abstracts multiple virtual instances on a single server. Right, so server virtualization also masks server resources, including the number and identity of individual physical servers, processes, and operating systems. So we've got traditional computer hardware and software designs that typically support single applications. So often this forces servers to each run a single workload, essentially wasting unused processors, memory capacity, and other hardware resources. Server hardware counts spiraled upwards as organizations deployed more applications and services across the enterprise. The corresponding costs and increasing demands on space, power, cooling, and connectivity push data centers to their limits. But here's where the advent of server virtualization changed everything. Virtualization adds a layer of software called a hypervisor to a computer, right, which abstracts the underlying hardware from all the software that runs above. So a hypervisor organizes and manages the computer's virtualized resources, provisioning those virtualized resources into logical instances called VMs or virtual machines, each now capable of functioning as a separate and independent server. So virtualization can enable one computer to do the work of multiple computers, utilizing up to 100% of the server's available hardware to handle multiple workloads simultaneously. So you see how this reduces server counts, eases the strain on data center facilities, also improves IT flexibility while lowering the cost of IT for the business or enterprise. Virtualization has literally changed the face of enterprise computing, but its many benefits are sometimes tempered by factors such as licensing and management complexity, as well as potential availability issues. So organizations have to understand what virtualization is, how it works, its trade-offs, as well as use cases. See, only then can an organization adopt and deploy virtualization effectively across the data center. Let's dig in a little deeper. In order to appreciate the role of virtualization in the modern enterprise, consider a bit of IT history, will you? Take a walk down memory lane. Virtualization isn't actually a new idea. The technology first appeared in the 1960s during the early era of computing mainframes as a means of supporting mainframe time sharing, which divides a mainframe's considerable hardware resources to run multiple workloads simultaneously. So virtualization was an ideal and essential fit for mainframes because the substantial cost and complexity of mainframes limited them to just one deployed system. Organizations had to get the most utilization from the investment. The advent of x86 computing architectures brought readily available, relatively simple, low-cost computing devices into the 1980s. Organizations moved away from mainframes and embraced individual computer systems to host or serve each enterprise application to growing numbers of users or client endpoint computers. Now, because individual x86-type computers were relatively simple and limited in processing, memory, and storage capacity, the x86 computer and its operating systems, OSs, right, were typically only capable of supporting a single application. Now, one big shared computer was replaced by many little cheap computers, basically. So virtualization was no longer necessary, and its use kind of faded into history along with those mainframes. But two factors emerged from the miasma that drove the return of virtualization technology to the modern enterprise. First, computer hardware evolved quickly and dramatically. So by the early 2000s, typical enterprise-class servers routinely provided multiple processors and far more memory and storage most enterprise applications could realistically use. Didn't this result in wasted resources and wasted capital investment? Because excess computing capacity on each server obviously was unused. So, it was common to find an enterprise server utilizing only 15, maybe 25% of its available resources. But the second factor was a hard limit on facilities. Organizations simply procured and deployed additional servers as more workloads were added to the enterprise application repertoire. Now, over time, the sheer number of servers in operation could threaten to overwhelm a data center's physical space, its cooling capacity, and its power availability. So the early 2000s experienced major concerns with energy availability, distribution, and costs. So the trend of spiraling server counts and wasted resources was actually unsustainable. Server virtualization was reemerging in the late 1990s with several basic products and services, but it wasn't until the release of VMware's ESX 1.0 server product in 2001 that organizations finally had access to a production-ready virtualization platform. And the years that followed introduced additional virtualization products from the Xen project, Microsoft's Hyper-V with Windows Server 8, just to name a couple, but there were many others at the time. So virtualization was maturing in stability and performance. And then, with the introduction of Docker in 2013, well, this just ushered in the era of virtualized containers, offering greater speed and scalability for microservices application architectures compared to those ancient traditional VMs. So today's virtualization products embrace the same functional ideas as their earlier mainframe counterparts, but virtualization will abstract software from the underlying hardware, enabling virtualization to provision and manage virtualized resources as isolated logical instances, effectively turning one physical server into multiple logical servers, each capable of operating independently to support multiple applications running on the same physical computer at the very same time. Now, I really cannot overemphasize the importance of server virtualization. It's been quite profound because it addresses two problems that plagued enterprise computing well into the 21st century. Virtualization lowers the physical server count, enabling an organization to reduce the number of physical servers in the data center, or run vastly more workloads without having to add extra servers. Now, this is a technique called server consolidation. The lower server count also conserves data center space, power, and cooling, and this can forestall or even eliminate the need to build a new data center facility. So in addition to all of that, virtualization platforms routinely provide powerful capabilities such as centralized VM management, VM migration, enabling a VM to easily move from one system to another, and workload and data protection through backups and snapshots. All right, so let's get into the nuts and bolts, or the virtual nuts and bolts in this case. So this server virtualization works by abstracting or isolating a computer's hardware from all the software that might run on that hardware. This abstraction is accomplished by a hypervisor, a specialized software product. There are numerous hypervisors in the enterprise space, including Microsoft Hyper-V and VMware vSphere. But it's this abstraction that essentially recognizes the computer's physical resources, including the processors, memory, storage volumes, and network interfaces, and creates logical aliases for those resources. So, for example, a physical processor can be abstracted into a logical representation called a virtual CPU or vCPU. The hypervisor then is responsible for managing all the virtual resources that it abstracts and handles all the data exchanges between virtual resources and their physical counterparts. The real power of hypervisor is not abstraction, but what can be done with those abstracted resources. See, a hypervisor uses virtual resources to create logical representations of computers, right? VMs. A VM is then assigned virtualized processors, memory, storage, network adapters, and other virtualized elements, such as a GPU, managed by the hypervisor. So when a hypervisor provisions a VM, the resulting logical instance is completely isolated from the underlying hardware and all the other VMs established by the hypervisor. So this means a VM has no knowledge of the underlying physical computer or any of the other VMs that might share the physical computer's resources. So this logical isolation, combined with careful resource management, enables a hypervisor to create and control multiple VMs on the same physical computer at the same time, with each VM capable of acting as a complete, fully functional computer. So virtualization enables an organization to carve several virtual servers from a single physical server. Once that VM is established, it requires a complete suite of software installation, including an OS, drivers, libraries, and ultimately the desired enterprise application. Right? So this enables an organization to use multiple OSs to support a wide mix of workloads, all on the same physical computer. The abstraction enabled by virtualization gives VMs extraordinary flexibility that isn't possible with traditional physical computers and physical software installations. All VMs exist and run in a computer's physical memory space, so VMs can easily be saved as ordinary memory image files. Then these saved files can be used to quickly create duplicate or clone VMs on the same or other computers across the enterprise, or to save the VM at that point in time. Similarly, a VM can easily be moved from one virtualized computer to another simply by copying the desired VM from the memory space of a source computer into the memory space of a target computer, and then deleting the original VM from the source computer. Now, in most cases, the migration can take place without disrupting the VM or user experience. See, so although virtualization makes it possible to create multiple logical computers from a single physical computer, the actual number of VMs that can be created is limited by the physical resources present on the host computer and the computing demands imposed by the enterprise applications running those VMs. For example, a computer with 4 CPUs, 64 gigabytes of memory, let's say it hosts up to 4 VMs each, with 1 vCPU and 16 gigabytes of virtualized memory. Now, once a VM is created, it's possible to change the abstracted resources assigned to the VM to optimize the VM's performance and maximize the number of VMs hosted on the system. Generally, newer and more resource-rich computers can host a larger number of VMs, while the older systems, or those with compute-intensive workloads, might host fewer VMs. So it's possible for the hypervisor to assign resources to more than one VM, and this is a practice called overcommitment. But it's actually discouraged because computing performance penalties are definitely incurred. The system must timeshare any overcommitted resources. So you want to talk about benefits, do you? Well, like I've been saying, virtualization brings in a wide range of technological and business benefits to whatever organization you're working for. But consider a handful of the most important and common virtualization benefits. So we've got server consolidation. Because virtualization enables one physical server to do the work of several servers, the total number of servers in the enterprise can then be reduced. So this is a process called server consolidation. And let's say, for example, there are currently 12 physical servers, each running a single application. So with the introduction of virtualization, each physical server might host 3 VMs, with each VM running a certain application. Then the organization would only require 4 physical servers to run the same 12 workloads. Simplified physical infrastructure. because with fewer servers, the number of racks and cables in the data center is dramatically reduced. This simplifies deployments and troubleshooting, and the organization can accomplish the same computing goals with just a fraction of the space, power, and cooling required for the physical server complement. Reduced hardware and facilities costs. Server consolidation lowers the cost of data center hardware as well as facilities. Now you got to remember, less power, less cooling. Yeah, so server consolidation through virtualization is a significant cost-saving tactic for organizations with large server counts. Greater server versatility. Yeah, because every VM exists as its own independent instance, every VM must run an independent OS. However, the OS can vary between VMs, enabling the organization to deploy any desired mix of Windows, Linux, or any other OS on the same physical hardware. Such flexibility is unmatched in traditional physical server deployments. We also can talk about improved management, because virtualization centralizes resource control and VM instance creation. Modern virtualization adds a wealth of tools and features that give IT administrators control and oversight of the virtualized environment. So, for example, live migration features enable a VM to be moved between two physical servers without stopping workloads. Data protection features, such as snapshots, can capture a VM's state at any point in time, enabling the VM to be recovered quickly and easily from unexpected faults or disasters. Virtualization lends itself particularly well to centralized management, enabling admins to see all VMs in the environment and deploy patches or updates with fewer chances of mistakes. So yeah, just like any list of pros and cons, there just might be some disadvantages to server virtualization. Yeah? Server virtualization brings a host of potential benefits to an organization. The additional software and management implications of virtualization software also bring numerous possible disadvantages that the organization needs to research and consider. We're talking about risk and availability. See, running multiple workloads on the same physical computer carries risks for the organization. Now, before the advent of virtualization, a server failure only affected the associated workload. With virtualization, a server failure can affect multiple workloads, potentially causing greater disruption to the organization, employees, partners, and customers. You see, IT leaders must consider issues such as workload distribution, which VMs should reside on which physical servers, and implement recovery and resiliency techniques to ensure critical VMs are available in the aftermath of server or any other physical infrastructure faults. VM sprawl. Yeah, this might be a new one for you. IT resources depend on careful management to track the availability, utilization, health, and performance of resources. Knowing what's present, how it's used, and how it's working are keys to data center efficiency. A persistent challenge with virtualization and VMs everywhere is the creation and eventual, though unintended, abandonment of VMs. You see, unused or unneeded VMs continue to consume valuable server resources, but only do little valuable work. Meanwhile, those resources aren't available to the other VMs. So over time, VMs proliferate, the organization runs short of resources, forcing it to make unplanned investments in additional capacity. You see where that's going. So that's why this phenomenon is called VM sprawl, or virtual server sprawl. Unneeded VMs must be identified and decommissioned so that resources are then freed for reuse. While we're on that subject, resource shortages. Because virtualization makes it impossible to exceed normal server resource utilization, primarily in memory and networking. For example, VMs can share the same physical memory space, relying on conventional page swap, temporarily moving memory pages to a hard disk so the memory space can be used by another application. Virtualization can assign more memory than the server has, right? Remember memory overcommitment? And overcommitment is undesirable because the additional latency of disk access can slow the VM's performance. Network bandwidth can also become a bottleneck as multiple VMs on the same server compete for network access. Now, both of these issues can be addressed by upgrading the host server or by redistributing VMs between servers. Let's talk about licensing. See, hypervisors and associated virtualization-capable management tools impose additional costs on the organization, and hypervisor licensing must be carefully monitored to observe the terms and conditions of the software's licensing agreements. So be sure you read those. Now, license violations can carry litigation and significant financial penalties for the offending organization. And in addition to all that, bare metal VMs require independent OSs, requiring licenses for each OS deployment. Experience. Successful implementation and management of a virtualized environment depends on the expertise of the IT staff. Education, training, and experience are essential to ensure that resources are provisioned efficiently and securely, monitored and recovered in a timely manner, and protected appropriately to ensure each workload's continued availability. Business policies play an important role in resource use, helping to define how new VMs are requested, approved, provisioned, and managed throughout the VM's lifecycle.